So after what you can say, going through the terms of titration, we need to calculate the concentration of the unknown solution, we need to calculate the volume of the unknown solution, we need to calculate the strength of the unknown solution, the percentage purity of the unknown solution. So many things will be asked to you. According to the question, we need to calculate. So now we will understand that after doing the titration, how to calculate it. That is what I am going to say to you. How to do the calculations. See, now in regular classes I talked about to you about that is nothing but W by W. I said you, alright. I told you about that is W by V. I said it to you into 100%, of course. W by W into 100%. Then I said you about W by V into 100%. Then I said you about B by V into 100%. All these things I said you, all these things. So W by W means where weight of the solute by weight of the solution. Generally, you can take the weight of the solution in grams, that is 100 gram, let us say. Similarly, weight of the solute by volume of the solution, which may be, let us say, 100 ml in ml. This volume of the solute by volume of the solution, in this way. So all these things are discussed in the regular classes. So this will be used now. Now next is some more formulas are there which you'll be using is that is you have learnt about molarity, isn't it? I told you this formula, percentage mass into 10 into D. D is the density of the solution by molecular weight of the solute. Now in terms of normality, if it will be asked, so what you need to do, percentage mass into 10 into D, that is density of solution, by equivalent weight of solute. Instead of molecular weight, we will do equivalent weight of the solute. You know how to calculate the equivalent weight, already we have discussed with you. Equivalent weight of acids, equivalent weight of bases, equivalent weight of oxidizing agent, equivalent weight of salt, equivalent weight of an element. Already we have discussed all these things with you. So basically you will be using another these two formulas, you will be using it, got it, for calculation. So these are the formulas, you will be using it, got it. It depends upon the question, that in the question what is being asked to you, accordingly you will be using the formulas, just I am saying you. Now next is we will be coming across different types of solution. When titration we are doing, basically it undergoes what? Neutralization reaction. It also results in the formation of precipitation reaction, because sometimes it may form a precipitate also. Then also it may result in the formation of complex formation reaction. Now what do you mean by complex formation reaction? Complex formation is, that is, suppose I take here AgNO3 and I take here KCN. Alright, what is going to form? It is nothing but going to form KAgCN whole twice. This is a complex. Alright, KAgCN whole twice plus this is your K, unacetate potassium, and we will be getting nothing but KNO3. You will balance it later on. You will be balancing it. So KAgCN whole twice plus that is nothing but KNO3. So if you balance it also, how much it is? CN whole twice, na? So CN. So 2K are there, we got it. Similarly, suppose if you take here CuSO4 plus ammonia. So what you will be getting it? You will be getting nothing but CuNH4 whole twice SO4. Alright, Cu, that is NH4 whole twice SO4. We can say that you will be getting it. So in this way, you will be getting this sort of reactions. This particular reactions are known as complex formation reaction, because the product is a complex here. This is a complex product, you will be getting it. In class 12 when you will go, you will be studying about a chapter that is called coordination compound. So this is a coordination compound which forms. Got it? You will be studying later on about it, which is a complex compound, we can say that. Clear? Where this is a complex ion and this is a simple ion. Here this is simple ion and this is a complex ion. Inside the bracket it is said to be as complex ion, and outside the bracket it is called as a simple ion. Very simple. So in this way, different types of reactions is going to take place. Either nucleation reaction takes place, or precipitation reaction takes place, or complex formation reaction takes place. What a different types of reaction is going to take place. Fine. Now after this type of reactions, now we will see, that is we'll understand it, that when we'll be taking the oxidizing agent. Got it? Suppose we are doing oxidation reduction titration, we are doing it. Alright, oxidation reduction titration. In oxidation reduction titration, generally we take an oxidizing agent and we go for oxidation reduction titration. So what is the oxidizing agent we take? Either potassium dichromate or potassium permanganate. Generally these are the oxidizing agent we take it. Got it? During titration. In the lab, because this is readily available in the lab. Got it? Otherwise there are many oxidizing agent is there, nitric acid is there, manganese dioxide is there, many are there. But one which is readily available, that only will be using it na, for doing the titrations, isn't it? Achha. Now next is when we go for titration, we do titration in acidic medium, like we say acidified KMnO4. We do it in alkaline medium, like we say alkaline KMnO4. We do it in neutral medium, we say neutral KMnO4. Alright. So in that particular case, what it happens? Alright, when we take acidified KMnO4, what is the reaction? When we take neutral KMnO4, what is the reaction? When we take alkaline KMnO4, then what is the reaction? So those reactions will be given to you. No need to learn the reactions, but you need to understand the reactions. Got it? The reactions will be given to you in your exams. Don't worry about it. You may ask, sir, reactions we have to learn it. If you learn it, it's well and good, but it is not required. It will be given to you. I remember it, so I am saying you. Are you following? When the reactions is going to take place, I've said you different types of reactions is there. Apart from these reactions, that is neutralization, precipitation, complex formation, we have also got what you can say redox reaction, that is oxidation reduction titrations. In case of oxidation reduction titration, I said you will be using the oxidizing agent. Now oxidizing agent, when you will be using it, you will be using oxidizing agent in different medium. You will be using in acidic medium, like we say acidified KMnO4. You will be using in neutral medium. You will be using in alkaline medium. So when you use in different medium, what happens is that a different reaction takes place. That you need to understand. You did not have to learn it. If you learn it, it's well and good, no problem. But if you have to understand it, understanding is a must. Alright, clear. Now, next is we'll go for what you can say acidified KMnO4. That is in acidic medium I'm taking it. Clear. So when I say acidified KMnO4, what do you mean by that? See, KMnO4 plus H2SO4. That is acidified. As for acidification, what do we require? We require an acid. So basically for acidification, we take dilute sulfuric acid, not hydrochloric acid or nitric acid. Why? Because dilute sulfuric acid is a non-volatile acid, and hydrochloric acid and nitric acid is a volatile acid, and volatile acid never used. Alright, because it volatilizes at low temperature. So what you will be getting it? See, KMnO4 and H2SO4. So it's very simple. Here two cations are there, potassium and manganese, and anion is there, sulfate. So very simple. K2SO4 plus MnSO4. First of all, it forms. In this way, you have to understand the equation that K2SO4 and MnSO4 is being formed. Then what will happen? Water will be formed. And what will happen? As it is an oxidizing agent, it will give you nascent oxygen. As it is an oxidizing agent, it will give you nascent oxygen. So in acidic medium, when you will balance it, you will get 5 nascent oxygen. Alright, that is, you will be balancing 2 KMnO4 and 3 H2SO4. So already why 2? So I have written K2. Alright, why it is 3 H2SO4? Because here 2 Mn I have written. So 2 Mn here I have to write it down. So 2 SO4 and 1 SO4. So hence it is 3 SO4 we got it. Got it? And how many water it is? 3 water and 5 nascent oxygen we got it. Now you might be thinking, why I am writing this equation? Just to know the nascent oxygen here. Alright, what will I do with the nascent oxygen? I will get the equivalent weight. Alright, because what I said the formula to you, normality is percentage mass into 10 into density by equivalent weight. So I need the equivalent weight of the particular substance. So what is the formula to calculate the equivalent weight of a particular substance? Molecular weight by, what is that? Number of electrons lost or gained. So here the equation is not an ionic equation. The equation is a molecular reactions. In case of molecular reactions, we want the nascent oxygen. We want the nascent oxygen in a molecular reaction. Suppose the reaction would happen in this, like KMnO4 means MnO4 minus. Alright, from here you see MnO4 minus. What it gives you? It gives you MnSO4. So what do you get it? Mn2 plus. MnSO4 means Mn valence is how much? 2 plus, because sulfate is 2 minus. So Mn valence will be 2 plus. So KMnO4 to Mn2 plus. If you balance this equation, then you will be getting how many? Same you will see, same number of electrons you will get it as the number of nascent oxygen. You will balance it. I have taught you already the balancing. See, once again I will tell you how to balance it. So Mn balanced. See here. Oxygen 4. So what I said you add here 4 water. Alright, remember it. See what I said, how to balance it. 4 oxygen, so 4 water. As many oxygen, that many water. Now 4 water means how many hydrogen you got it? 8. So hence what will I do? I will do 8H plus. Clear? 8H plus I got it. Now Mn is balanced, oxygen is balanced, hydrogen is balanced. So I need to balance the charge. Here the total charge is how much? Plus 2. Here the total charge is how much? 8 minus 1. It's how much? 7. So how much I want? Both sides 2. So hence what I have to do? I have to subtract 5. So what will I do here? Plus 5e minus. Because plus into minus is minus. Plus into minus. Minus. So 7 minus 5. How much you get it? That is nothing but 2. Is it clear? Once again you check it. whether we are correct or wrong. Here it is C, plus 8. And it is here minus 1. How it is minus 1? Array, here plus sign is there, no? Nothing is in plus. Plus into minus is minus. Here plus into minus is minus. So minus 1 minus 5. How much is this? 8 minus 5 is 3. 3 minus 1 is 2. So we get it plus 2. And here it is already plus 2 is there. So it is balanced. How much we get it? How many electrons we get here? 5. But we learned the formula earlier in the regular classes. What I said you? Equivalent weight of an oxidizing agent is nothing but the molecular weight of the oxidizing agent. Which is the oxidizing agent? This one. So molecular weight of the oxidizing agent by number of electrons lost or gained. How much we got it? 5. Now this is for the molecular, for the ionic equation we got it 5. For the molecular reaction same 5. But 5 not electrons here. 5 is what? Nascent oxygen. Got it? So whichever process you do, the answer will be the same. Answer will be the same. So here, what is the molecular weight of oxidizing agent? KMnO4. You will find it out. It is 158. Alright? It is 158. Clear? Divided by 5 you will do. Here also same thing. Same molecule. What is the molecular weight of oxidizing agent? Don't say sir MnO4 minus. MnO4 from minus from where you got? You got from KMnO4, na? Alright. So hence same it is 158 divided by 5. Clear? For molecular reactions you need nascent oxygen. So what you can say, molecular weight of the oxidizing agent by number of nascent oxygen. For ionic equation you need the what you can say, number of electrons. Same thing, molecular weight by 5. So it depends in which way the equation is given to you. Whether the equation is given in ionic form, whether the equation is given in molecular form. Alright, that you need to understand. So this is an acidic medium. Similarly, we have got alkaline medium. Similarly, we have got neutral medium. Understood now? Those, whichever medium is there, it will be given to you in your exams. It will be written clearly in the, what you can say, question. Now you will say, sir, how will I know? See, H2SO4 is given, na? From that we know. We come to know. Here H plus is given, na? From that we come to know. That is acidic. If it is basic, it will be OH minus. And here it will be either NaOH or KOH something. And in neutral, water will be there. That's it. Clear? So what you need to do, if the ionic equation is there, I need to find number of electrons, and if molecular equation is there, I need to find the nascent oxygen. How to find the equivalent weight? Equivalent weight is nothing but molecular weight of the oxidizing agent divided by number of nascent oxygen, or molecular weight divided by number of electrons. Whichever form the equation is given, you do it accordingly and you find it out. Alright? So in this way, here medium will be given. According to different medium, different reactions. And different oxidizing agent, different number of nascent oxygen, different number of electrons. Got it? Thank you very much.